Okay, hi, good day, class. So, as promised, today will be a short one. Okay, all right. So, we have learned the scalar product, dot product, and also we have learned the last video. We have learned the vector product, or we call it cross product. All right, with this formula. Okay, so today we will see how we can find the area of triangle and parallelogram by using vector product. So of course you have learned how to find area of triangle by using different way, and also the area of parallelogram. Okay, now we will see how to use this vector product to find the area of the triangle and also parallelogram. All right. Okay, so as you see, let's say you are given a parallelogram OABC. OABC. All right. So let's say OA is represented by vector A, OC represented by vector B. Okay. Then from A, we draw a perpendicular line to OC here. Okay. So let's say this is H lah. All right. This length A is H. All right. So by looking at this triangle, okay. So if this is the angle theta, so you see A and B come up from the same point, means diverge from the same point. So this is a theta. All right. So you can see that in this one, the sine theta is opposite hypotenuse. So H over modulus A. From here you get that H is modulus A sine theta. How you get this thing? All right. So OABC is a parallelogram with vector A and B as the adjacent side. So when you are given a parallelogram, when we say adjacent side, means the two sides that came out from the same point or diverge from a same point. All right. So the area of the parallelogram of OABC will be, so we know that actually parallelogram is similarly to rectangle. So the area of rectangle is height multiplied length, right? So for parallelogram, if this is the length, then the height should be a line that perpendicular from the opposite vertex to the opposite side. All right. So same. So it will be H modulus B lah. H modulus B is the area of the parallelogram OABC. And H, just now we have calculated, H is modulus A sine B. All right. So when we rearrange it, so the area of parallelogram will be modulus A modulus B sine theta. All right. So modulus A modulus B sine theta is actually equals to A cross B modulus of A cross B. Remember, A cross B, the formula is modulus A modulus B sine theta multiplied with n hat. All right. So when modulus of A cross B, then is the modulus of this whole thing. So we know that it's a unit vector. N hat is unit vector. So the modulus is 1. So we can omit it. All right. Therefore, modulus A modulus B sine theta will become modulus of A cross B. Okay. So as conclusion, the area of triangle OABC will equals to modulus A and B. So remember, which one is A, which one is B. So A and B should be the adjacent of this parallelogram. Okay, you cannot simply use other side. All right. Okay, then if you can find the area of parallelogram, then no problem for us to find the area of triangle OAC. So this is a parallelogram. So triangle OAC, anything. You can say triangle OAC, you can say triangle ACB or ABC. Okay, you also can say triangle OAB or triangle OCB. All right, so any triangle that inside this parallelogram. All right, so will be half of the area of parallelogram OABC. We know, right, in the parallelogram the triangle is half of it. So it means half of modulus of A cross B. All right. Also, of course, this one and this one not the same meaning. This is multiplied, this is cross. Okay, not the same meaning. All right. So this is how we can get the formula. Okay, how we find the area of parallelogram and triangle by using cross product. All right. So in your textbook, there is actually another alternate way to get these two formula. You can refer to your textbook, page 264. Yeah, here. Okay, this part, page 264. All right. They show you this thing. and they use the concept of AB sine C that you have learned in Form 5. They use the concept of AB sine C. All right, you can go back and study yourself lah. Of the same formula but different way to get it. All right. Okay, so we will discuss some example. Okay, so checkpoint 6.3. So last video we have done checkpoint 6.3. Okay, question 1 to question 7 related to the vector product. All right, so today we will continue question 8 to question 10. All right. Okay. So 8 and 9 will be your homework. So I just explain a bit. Okay, so for question 8, the position vector, you are given that the position vector of A, B, and C are this one. All right, so means this is OA, OB, OC. Find AB cross AC, anchor BAC, and the area of triangle ABC. This question, the diagram not given. You can sketch yourself. All right. Yeah, you can actually sketch yourself. All right. All right. So let's say I sketch. This is triangle ABC. Okay. So because the question 1 AB cross AC, AB cross AC. So this one will be the anchor theta lah. Correct lah, huh? They want anchor BAC mah. BAC. All right. So no problem, right? Since you already have OA, OB, OC, so you can find AB. Remember the position vector? AB is OB minus OA. Then you can find AC. AC is OC minus OA. Then you find the cross product. All right. Then from the cross product, you can find the anchor. All right, that we have mentioned just now. All right. The modulus of the cross product is modulus AB, modulus AC sine theta. Right? So you can, from there you can find the sine theta and find the area using the formula that we have discussed just now. All right, the area of triangle is half modulus A cross B, means AB cross AC. Okay, then for question 9, here. Okay, sorry, it's shaking. Okay. All right, so this is question 9. So question 9, you are given the coordinate for point A, B, and C. Actually, when you are given the coordinate, you understand that this is actually your OA, OB, and OC, position vector. And D are the vertices of the parallelogram. They never give what is D, but doesn't matter. Actually, we don't need. All right, so we sketch the parallelogram. Let's say A, B, C, D. I label it. Okay, find the area of the parallelogram. All right, so to find the area, we know that we need to cross two vectors, the adjacent of this parallelogram. So we can choose BA. You must follow the direction. We choose BA and BC as the adjacent. All right. So since you already have OA, OB, OC, so no problem for you to calculate BA. So you must use BA, not AB, remember? And to find BC, then you find the cross product. All right. The modulus of the cross product will be the area of the parallelogram. Later we will discuss 2 examples. So from there you get the idea. All right. Then a unit vector which is perpendicular to the plane ABCD. Remember what is the vector perpendicular to plane ABCD? So AB, BA and BC lies on this plane, right? Lies on this plane. So the cross product is a new vector. Remember, the cross product is a new vector, and this new vector perpendicular. Remember, perpendicular to BA and BC. So means perpendicular to the plane. All right. So use that concept. Okay. So I will discuss question 10. So question 10, you are given a cuboid like this. It show a cuboid, and you are given, you see this cuboid is PQRS TUVW. All right, and given that PQ is A, PS is B, and PT is C. Okay, so a diagram like this given. You're asking to prove that the volume of the cuboid is A cross B dot C. Okay, it's more on concept lah, So I will discuss question 10. Okay, so this is question 10. Okay, you can see the whole paper. This is question 10. All right, okay. So remember, question 9 and 8 will be homework. So I redraw the diagram. So this is the diagram. Okay, so this is A, B, and C. So we know that first we calculate the area of PQRS first. the base, PQRS. So we know PQRS is the modulus of A cross B, right? Then the volume. Volume means we use the area of PQRS, the base, multiplied with the height, right? This is how to calculate the volume. All right, the area of PQRS multiplied with the height. All right, therefore, the area of PQRS is modulus A cross B. Okay, and the height is modulus C. You see from here, I don't use the sign multiply. Because in vector, this is more to vector product. I don't use multiply. All right, so I use bracket to show this modulus multiplied with this modulus. Okay, how we can change this modulus multiplied, this modulus become this? We cannot simply remove, right? We cannot simply remove the modulus. It's actually come from this concept. All right, the first concept is the dot product. Is some revision let's say I have two vectors, vector x and vector y. So if x and y are parallel and same direction like this, means theta is 0, right? So by using the dot product or scalar product formula, so x dot y will be modulus x modulus y cos theta. And the angle now is 0 and cos 0 is 1. All right, therefore, if two vectors are parallel and same direction, so x dot y will be same as modulus x modulus y. Okay, so this is one of the concept. All right, another concept is here. From this cuboid, it's very clear that vector C is perpendicular to A and B, right? Because this is a cuboid. So vector C is actually perpendicular to the base PQRS. Means is perpendicular to A and B. Alright, then we know that the cross product of A and B, cross product of A and B is another new vector. And this new vector also perpendicular to A and B, right? Okay, so since C perpendicular to A and B, A cross B also perpendicular to A and B. Therefore, we know that C and A cross B are parallel. Correct, right? So C is perpendicular and A cross B also another vector. This is A cross B, another new vector which is perpendicular to A and B. Therefore, the conclusion is A cross B parallel to C. A cross B and C are parallel. All right. So if A cross B and C are parallel, so we go back to this concept. You see? If x and y are parallel and same direction, then x dot y equals to modulus x modulo y. See? So if A cross B and C are parallel, then A cross B dot C will be modulus A cross B modulus C. Right? Using this concept. X dot y is modulus x modulo y if they are parallel. Therefore, A cross B dot C also will be equal to modulus A cross B modulus C because they are parallel. Okay? Yes, from here we get this conclusion, then we apply here. Okay, then we apply this one here. We already have this modulus A cross B modulus C. We already have this one. And from this fact, we prove that this is actually equals to this one. Yes, it's A cross B dot C. So we can just remove the bracket because remember, cross and dot definitely this one have to do first. We have to do the cross first because after cross is another vector, another new vector. So vector only can dot with vector. We cannot do this part first because B dot C is a scalar. Alright, so a vector cannot cross with a scalar. So understood lah. We can just remove the bracket and write in this way. This is what we want to show. Okay, you see, a simple question, but we apply the concept that we have learned, the dot product and the cross product concept. All right, so this is question 10. Okay, so next, so just now checkpoint 6.3 lah, 8, 9 homework, so 10 I have discussed. So there will be another question here. I'm going to discuss this question. But, okay, this question, mistakenly the diagram actually blocks some wording. The diagram actually blocks some wording, so I have reprint it. Okay, it's supposed like this. Alright, I have reprint it. Can see? Okay. All right. Okay. Can see the whole paper. Oh, I have reprinted it. So this is a question. Okay. So after I've discussed this question, then you have no problem to do just now question 8 and 9. All right. So in the diagram, O, A, B, C, D, E, F, G is a cube. O, A, B, C, D, E, F, G. It's a cube. Cube, you know what? All the sides are the same. Which each side has the length 12 units. All right, 12 units. Okay. And the unit vector I, J, K are parallel to OA, OC, and OD respectively. Means OA is in terms of I. OC is J. OD is K. Not, I mean in the direction. So very simple. For example, so from here you can say that, I write here. OA, this one, OA, is in terms of I, right? And how many I? Just now we say, right, the length is 12. So OA is 12 I. Alright? So OC will be 12 J. OD will be 12 K. OC 12J. Oh, sorry. This one. OD 12K. Alright. OA is 12 I. Okay? So these are the information given. And then point N is such that AN is 1/3 of AB. N is here. See? N lies on AB. So the question tell you AN is actually 1/3 of AB. Okay? 1/3 means here 1 part, here 2 part lah. So altogether 3 part. And M is the midpoint of DF. When we join DF. Alright, this diagonal DF. M is the midpoint of DF. Okay, all this information given. Okay, part A, you are asking to express vectors OM and MN in terms of IJK. And B, determine the angle OMN to the nearest 0.1 degree. Okay, I added in C lah. So C, find the area of triangle OMN. Alright, okay, this is the question. Okay, let's see the solution. Okay, so first they want you to find OM. So OM, from this diagram, can see OM is here. Okay, Lula. I hope you see lah. So this is OM. Okay, OM. So OM is OD DM, right? OM, I can write as OD DM. Alright, OD DM. Okay, OD just now we have said 12K. Alright, and DM, because M is the midpoint, so DM is half DF, right? Then this one is again 12K, half, and we know that DF actually same as AB, OB, right? DF same as OB, because this is a cube. Alright, so DF same as OB. And what is OB? What is OB? OB is OA plus AB, right? OB. So OA plus AB. Alright? And OA is 12I, right? And what is AB? Actually, you see AB same as OC, right? AB same as OC. AB same as OC, yeah? Okay? And OC is 12J, right? Yes. It's just that simple. So when we simplify it, so half multiplied 12, 6I. Half multiplied 12J, 6J plus 12K. So this is your OM. Alright. Then next, the question wants us to find MN. MN. Yeah, here. Yes. The question wants us to find MN. Alright, start with MN. So to get MN is same as OA, MO, MO, right? To get MN, I can use MO plus ON. Alright? MO, this is OM. This is OM. So MO, negative, right? Negative vector. So become MO is negative 6i minus 6j minus 12k from here, but all change to negative. All right? Okay, then what is ON? ON. So ON is OA-AN, right? OA-AN. Okay, so again, OA is 12i, and AN is 1/3 of AB. See, from here. AN is 1/3 of AB. AB is 12j, right? Just now we already said here. AB is 12j. Okay, so we just simplify again. So this is minus 6i plus 12i, so 6i. Minus 6j plus 4j. This is 4j, right? So minus 2j. And minus 12k. Okay, so this is your MN. Alright? Okay, next. B. Determine the angle of OMN. OMN. So I draw out this triangle lah, easier for you to see. I draw out the triangle OMN. The red color one, I draw it out separately so you can see better. Okay, so the question one, the angle of OMN, this one. So I name it as theta lah. Okay? So when see triangle and find angle, so we know that either you are using cross product or you are using dot product. Same. You can use cross product, you can use dot product, up to you. Alright? If dot product or scalar product, it involves cos theta. But if I use cross product, then it involves sin theta. Same. Okay? So which one you want to use also same. But because we want to find the area, so I use cross product lah. Because later to find area, I need cross product. Okay. Alright. So we know that because the anchor is here, right? Theta is here. So I know that the vector that we are going to use to do the cross product must be diverged from the same point. So means I need vector MO and vector MN. You must decide the correct vectors to do the cross product or even dot product also. Or you must determine the correct vector. So I can use MO cross MN. Okay, so from the formula, MO cross MN is MO MN sine theta and N hat. Alright, but we want the modulus only because we want to sine theta. So we straight away go to modulus so we can omit the N hat. Alright, so I do separately lah, or else too long. Okay, I'm going to do MO cross MN here. MO cross MN. So IJK, MO is, this is OM, MO is minus 6, minus 6, minus 12. Okay, MN here, 6, negative 2, negative 12. Alright, still remember how to do this. Okay, first is component for I, so cross this one. So positive 72, positive 24. So 72 minus 24i. Then component J, cross this one and this one. This is 72. This is minus 72. But minus so 72 minus negative 72 plus lah. And the second component, the sign is negative one, remember? Okay, and the K component, so cross here. K component is positive 12 minus negative 36. So plus 36 lah. Okay, so from here we get the cross product is 48i minus 144j plus 48k. And the modulus for this vector will be 48 squared plus 144 squared plus 48 squared. After simplify, it's 48 square root 11. Okay, then sub in here. Sub in here. Okay, what is the modulus for MO? So this is MO. So modulus is 6 squared plus 6 squared plus 12k. Alright, and MN, this is MN. So 6 squared plus 2 squared plus 12 squared. Then sine theta. Okay, so simplify the first one is 6 square root 6. Simplify the second one, 2 square root 47 sine theta. Therefore, sine theta is this one. These two shift to this side. Then use calculator to simplify it. This is sine theta. Therefore, theta means angle OMN. Because the question say find angle OMN, so we write it back. Press your calculator, shift sign this value. And the question one to the nearest 0.1. The actual value is actually 52.99. Alright, so to the nearest 0.1, 53.0. Don't just write 53, okay? Remember to write 53.0 degree. Okay, so B have done. This is actually quite standard STPM question. Okay, C, find the area of triangle OMN. Alright, so area of triangle OMN, half MO cross MN. Remember, the two vectors that you use to do the cross product must be diverged from a same point. So for this triangle, I use MOMN since this one have done. Okay, so just now from here, we already got the modulus. Therefore, the area of the triangle is 24 square root 11. So use some time to study this question. It's quite actually standard STPM question. Where involve all the so many concept of vectors that we have learned. Okay, finish. Alright, so today we just do this part lah. Use cross product to find the area of triangle and parallelogram. Okay, after 2 examples discussed, so I think no problem for you to solve 8 and 9. It's quite simple. Okay, alright, thank you class.